With this stuff this far, I want to begin to look at the current draw, just to make sure none of these chips are drawing excessive current. I don't see anything that's in backwards, but it does happen. I'm just eyeballing everybody again. So what I've got is, again, I'll use the switching power supply. I broke into the 5 volts here, where the 5 volts comes in. So I got the 5 volts from the supply coming to the ammeter, to the 5 volt input, and then ground out, and that'll let me measure current on the 5 volt rail. So assuming nothing goes bang, I find that a little hard to believe. It's only drawing 1.34 milliamps. Nothing is active or clocking, but that seems... I am in the wrong. I don't know why that's reading the way it is. Come on, unplug, dummy. Milliamps, microamps, and amps over here. I was in the wrong. Now let's plug it back in. Get an actual overflow. Okay. Okay, that makes more sense to me. 395 milliamps. You know, the 7400 down here should be clocking. Should be and is, of course, are two different things, but it should be. That oscillator should be running. I believe this oscillator should be running. So they are going to draw some current. This is clocking some of the chain here at least. You know, it calls for 5 volts at 1.5 amps. So at this point, being at 395 milliamps seems reasonable to me. If I could spot the logic probe. Oh, here it is. We poke around here a bit. I didn't intend to do this at this step, but why not? So let's get on ground. Can I get on a ground someplace? Clip on there, and I should be able to clip on here and pick up +5. And if we poke around at pins here, we may see something clocking, and we may not. Okay, so we do have something clocking here, which does say there's an oscillator running there. There's an 04 here. And there seems to be an oscillator running here as well. So those two oscillators seem to be doing something. I'm a little disturbed. That must be floating at this point. Well, that must be normal for that. Anyhow, so there is a bit of activity. We don't have a dead short, which is good. So I'm going to turn down the power supply. For now, I'm going to move this out of the way. Actually discharged. Well, it should be discharged by now completely. And let's go on and locate some of the logic. There should be an LS290. Boy, these are dirty. So now we want to do some cleaning before we insert. Everything here was so grubby. So because I kind of kept these similar to the layout on the board, I know where they would go back in, is the point. So there's a 290 and 290. Those pins are okay. So we'll put the 290 back where it came from. We've got a 242 above it. There's a 242 right here, as there should be. Again, the pins are okay. They're not super shiny, but I can live with them. There's a 293 here. And there's a 293 here. And this is one of those parts I find upsetting, and that the markings are upside down. Wow, those leads are actually pretty grubby. So I guess it's time to attempt to do some lead cleaning. Let's see, we'll start out with the brass wire. See if we can have any luck shining those up. The only thing I've really found that works for this, I hate to say it, is the fiberglass. I've tried Brasso and other silver polishes. I've just found nothing that... No, that's really not doing anything. I'll try steel, it's stiffer. It is having an effect. I'd much rather be doing this with steel. The way I don't get little bits of fiberglass in my fingers. Oh, I bent a bunch of pins up doing that. There's a 293 that goes here. There's a 242. Those aren't horrible. They're not great. That goes here. Got the 04 in. There should be a 164. Yeah, 74 164. It's a part I did not have. Oh, those leads are bad. This is the reason we didn't want to. Certainly cleaned up the inside of the leads. Maybe that's the way to do it. Oh yeah, looking much better. That's the way to do it. This way the pins don't get bent. Okay, that actually looks respectable again. 164 goes here. There is a 343. Leads look absolutely fine. That came out of this socket. We'll go right back into it. And another 343. I am looking at the markings on the device again to make sure that it's correct. I'm going to have to order some refills. That steel actually is working pretty well. And there are little bits of wire breaking off, but you can see them. Versus the fiberglass, where you just get the little bits and you really can't see them. We've got a... Let's do a bit of cleaning. So we should have a... Those leads look fine at 241. Goes there. Let's see, we 243s. Yep, there's two 243s. They go up here. That looks absolutely fine. I don't think it needs the leads. Another 243 here. That would have been that 04 there. So this, let's see, we've got a 7445 here. Leads look fine. There was meant to be an 8116 baud rate generator here with a crystal, that instead this oscillator can has been substituted in for. And the leads on it are pretty soft. So whatever I'm assuming it's ending up with a fixed baud rate. And that looks like it's in. Hopefully all the pins are in. Nothing got bent. Is there anything else? Yeah, this guy right here. Right there, I'm sure. It's an LS 241, LS 241. Pins are reasonable. I think that really is probably everything off that one. We had this one. There's the 4 there. There's this set here. So we're going to want, that should be a 290 there. It is. Try to clean it up a bit. Leads are reasonable. We should have a 393. 393. Yeah, LS 393. Okay. No, wait a minute. I am looking incorrect. It's the third row. 283. So it's going to be this guy and this guy. This is a 283. Oh, those leads are horrible. Let's attempt to clean it up here. So much better. This does actually knock a lot of that black off of them, that oxide, whatever it is. Yep, much more reasonable. The 283 goes here. And there should be a 3. Another 283, which is right here. I do believe. Yep, and its leads are just like the other one. Just ugly. Seems like putting pressure down on the device this way to clean the outside of the leads keeps them from getting pushed around and messed up. I am into my anesthetic surface here, meaning that the leads are poking into it slightly. So we've got some mechanical stiffness being created. Yep. It's not quite as great down here. Compared to what we started with, these leads are much better. I don't feel like I'm going to have connection issues, reliability issues in the near term. 2 right there. We've got the 2114s. I'm not going to put them in yet. We've got 243s and a 136. Oh, those leads are horrible. This system might have ran, well, we had that -5 volt solder miss on the 1D RAM. The monitor may or may not have come up. I'd have to look closer at the architecture and what bank is what bank. We talked about that in the video where we fixed the, or we soldered the missed solder joint. You are 153? Or is that 151? It's so hard to see. For LS. I really can't read that at the moment. Get it up here in some bright light. 1. It was like 136. Ah, okay, 136. It is a 136. It goes right here. And then there's 2 243s, which are these two guys. Which, based on the other 243s, I think the leads are fine. Two more 243s. So I'm gonna, just because I've been wiping off the tops of all of them to remove that little bit of oil and grime, whatever it is. We'll hit these as well. If I can get them out of the foil or the foam. These are a little dull, but they should be fine. And we've got the 1488s and the 1489s. These look okay. These are, of course, the RS-232 line drivers receivers. 1488. And again, it's good to see the correlation of the parts I pulled out, orientation match with the drawing. 1489. And 1489. Couple of devices missing here. which is an 8216 and an 8216. This whole block here really represents that. These were these. This was that. $151 and $174. $151, $174. Were those on here? Yeah, those were on here. Okay, there was a third piece that captured all of the DRAMs and this first row right here. And this is where the 157s had this weird doubled up thing that we don't fully understand. But we'll go ahead and put the doubled up ones back in. And there should be a oops, almost all evaporated. So let's go ahead and yank these. Under the assumption that there's a reason those are doubled up. The fact that every pin is soldered is really weird. You wouldn't piggyback like you sometimes do with a DRAM. You just replace the part. $82.16. 82.16. Pins look okay. $82.16. Pins look okay. So we expect these to be open. We expect those to be open. That, expected. All of those. I think we've got all the logic in we expected to have in. Device looks like it's sitting funny. I guess it's not. So that really looks like all the logic is in. We can the steel wire one here worked pretty well. Got those on Amazon. Let's get over here and get back to ammeter mode. Again, I would expect the current to go up. What was it, 390 milliamps, something like that before. That's an amp, just at 1.07 amps. And it's fair amount of logic. Power supply is good for 5 amps, so I don't think there's an issue there. There's a fair amount of logic there. There's at least some activity. There's most likely attempting to generate video here, would be my guess. I'd guess, everything is running there. The video output, I think, is that header right there, but I could be wrong. No smoke. Not feeling anybody getting warm. bit of warmth there on that 138. Nothing trying to burn my finger. So I'm just going to let this sit here and bake for a bit, and we'll come back and see if anything's gotten overly hot, and we'll go from there. So if you got this far in the video, I appreciate it, and I'll see you soon.